Alright, well in this box we have a Neotec 2515C, and this was sent to me for repair, so let's open it up out of the box and see what we are dealing with. Aldi bags. Interesting. More Aldi bags. Interesting. There's the chassis. Anything else in the box? Nope, just more Aldi bags. First time I've seen something like that used as shipping material, but hey, if it works, gotta go with it. Let's check out the chassis itself. And oops, sorry. I think I hit the camera there. Yep, 2515C. Oop. So 25-inch standard resolution Neotec. And now that I think about it, I don't recall if it's dead or what the issue with it was. Let me see if I can look this up real quick. Sorry about that. Let's take a look here. Okay, so here's what the owner says. It came out of a Rampage World Tour. Originally it was working, but then it began making an intermittent ticking noise, and then it started developing horizontal white lines. Well, that's a classic symptom of the flyback going out, because if the longer it's on, the more the lines come into view, or if they start out in view and then slowly go away, or if the brightness drifts or the focus drifts. If you first turn it on and it's in focus, and the longer it's on, the more it goes out of focus, or vice versa. The flyback is absolutely going out. So we'll probably have to replace the flyback, but it was originally working, began making an intermittent ticking noise, and then it developed the raster lines. But now it turns on with the game for a few seconds and then just goes black. That's what the message here says. So I assume that means that it works and then it doesn't, but we'll check it out and see what we can figure out. The caps are all original. With the symptom of what they're describing, I absolutely am going to change the flyback out. I do have one in stock. I don't know what's going on with this here being bent over, and this is bent over flat, and this is installed on top of it. That shouldn't be like that. It's a REFA cap. It's a filter cap for all intents and purposes. I think somebody replaced this at some point and they smashed that resistor over. Not that it's causing any problem, but it shouldn't be like that. If we continue to look here, it's dirty, but nothing too bad. I don't see any burned up components. This is a very simple design and very easy to troubleshoot for the most part. It has all the normal, power. Here's your power supply section, and your vertical section, and your horizontal, and you have your coil here with. This is where I get. See, I've actually got another couple of these sitting around. That's where I get these from. Is these Neotec monitors that I find as spare parts boards. These devices here are what you adjust the width coil with, and they come in very handy for adjusting all the width coils across all the different chassis. So we'll just go ahead and leave that one in there. But okay, so I guess we can start by testing some components. I don't see any bulging caps right off the bat. I want to test the HOT, and I want to test the switch mode power supply chip. In theory, it should read exactly the same as the 74, 75, 2000, 5000 models. So we'll begin by testing the fuse. Actually, let's look at the neck board. Neck board seems okay, no broken pots. We're going to set all of our pots for color here to center. Okay, those were already centered. And then on the side here we have our gain pots. Blue was already in the middle. I'm sorry, red was already middle, green's already middle, but blue's turned down slightly. So we'll just put them all in the middle, so there we go. Otherwise, this seems okay. Yep, alright. So not going to worry too much about the neck board. Let's go ahead and test our fuse. So this has a switch mode power supply chip here, just like the 7475 2000 5000. So if this is bad, you're going to have ticking, or you're going to have just a totally dead monitor. So we'll test our fuse first, make sure that's good. Fuse is good. Let's go ahead and reseat it, make sure we have good tension on the tabs. Oh, nope, broke it. This tab was spread out, and I just simply tried to bend it back together, and because sometimes these can be spread out and have bad connections and cause intermittent problems. I just wanted to verify that wasn't an issue, and of course this one was spread open. I tried to close it and it broke the tab off, but that's no big deal. I can replace it very easily, so we'll have to do that before before we even try and power it on. So that's a bummer, but no big deal. Fuse was good. This one here is spread out a little bit as well. Can I close that one? Yeah, not too bad. Okay. So let's set our fuse aside. Okay, HOT is this guy over here. Let's test that. Just like any other HOT, you want to go to diode mode, and center is negative, and we should get 0.5. 0.439 is fine, and then same thing on this one. 0.440, HOT is good. I'm wondering if maybe just all of our problem is the flybacks, but we'll find out. Next would be, well, this shouldn't be like that. Not sure why this is installed there, but someone put it there, so it must serve some type of purpose. Okay, a switch mode power supply chip. If we're looking at it like this, I think what we should read here is turn it around this way, and if I'm not mistaken, it should read the same as our other 74, 75, 2000, 5000. And by that I mean if we go negative lead here to here, it should read a voltage drop. No, I could have it upside down. Yeah, I have it upside down. Okay, so let's turn it around this way. Alright, so if we go here to here, we should have voltage drop. Yep. Let's zoom in a bit so you can see a bit closer. Okay, here to here should be voltage drop. Here to here should be a voltage drop. Yep. Here to here I think should be 1.0 or 1.5. Oh, that's not right. I don't think that's right. Huh. I don't think that's supposed to read that way. We may have a switch mode power supply chip problem. I wonder if this should be the same part number. Where's my bag? This sort of thing is my bag, baby. Okay, let's take a look at our part number here. I've got a bunch of the chips here. I think what I'll do is if this doesn't read properly, I'm going to replace this chip. I'm scared to turn it on if the chip got taken out by something else, because I don't want to damage one of these. But I'm also interested to see what's going on here. I think I have like 10 of these, so they don't fail very often on the series of chassis they're supposed to go in. But I do want to see if the part number on here matches. Let's see, this says... I can't see it in there. 384... That's a TDA 4605. It should, in theory, be the same as this one. Get out of there, you rascal. There we go. UC 3842. Maybe they're not. Well, I could have swore they were the same, but maybe not. It should function the same way. So that's interesting. Well, we'll proceed from the assumption that it's good because, like I say, if that chip is bad, it'll be completely, totally, 100% dead. No life, no nothing. So if we get ticking or signs of life, then that chip's probably okay. There's no real light bulb test for this that I'm aware of, so we're not going to be able to do that. Actually, what I should do is cover that up again. Okay, so let's put this away. And I've got cap kit and flyback in stock for this, so we can do that if necessary. But I think what we'll do is we'll just go ahead and test it the way that it is, because I'm not confident in my reading of this. I'm not as familiar with this as I am on the 74, 75, 2000, 5000. So I want to see if it's actually totally dead. If it's not dead, then we can assume this is probably okay. And I want to eliminate that before we kind of go on. Because we know the HOT is good, we know our fuse is good. So I am going to have to change out this, let's get the iron going here. I am going to have to change out this fuse holder, which isn't a big deal. We can steal one from... we can steal one from here. No, we can't. I've already stolen it. Gosh dang it. Okay, we'll steal one from here. Nope, I've stolen this one too. 0 for 2. That one's too big. All right, here we go. Let's just take this one. Alright, that's out. Set that there. And we'll take this out. Can I do this way? Yep, there it goes. Can I install this the same way? Yep. Quick and easy. There we go. Okay, and let's reflow this. Alright, let's make sure we don't have any cracked joints here. Just before we turn it on. Yeah, seems okay. Alright, well, let's go ahead and snap our fuse back in. There she blows. Well, that one's kind of... Let's get this back out of here. Why is that all bent around like that? That's... Okay, now that's better. Let's get that to snap in there. Hot Chimachi. Alright, so let's get a picture tube, get this hooked up, and just see what it's doing. Because I want to see if it's ticking or if it turns on. If it turns on and it works, I'm just going to do a cap kit, a reflow, and a flyback, and then we'll see at that point. Because it may be just fine, and it's just bad caps or bad flyback causing the problem. But generally speaking, yeah, if it's totally dead, you usually have an issue with the power supply chip here. Or if it's ticking, you got a bad HOT, but that tests good. So the fact that this is good, I'm fairly confident that nothing is actually shorted or wrong or bad. So I think possibly that we just may have, you know, this is your voltage regulation circuit over here. I mean, we can test our resistors here in the power supply section. Let's go to ohms, and we should have 2.2K on this one. Yep. This one should be 10K. I'm going to have difficulty testing this one. This one should be 10K for R114. Yep, 10K. So our power resistors are good. So yeah, I'm fairly confident that we'll probably just need a cap kit and a flyback for this. So let's just go ahead and turn it on and make sure our B plus is reading. I think it's supposed to read 120. I'll have to look it up. But you adjust it from right here at this pot's where you adjust your B plus. This is your power supply section for voltage regulation and generation, and the HOT horizontal circuit and vertical circuit. The vertical IC is attached to this heatsink here, right in there. So vertical circuit, horizontal circuit, power supply section, things like that. So let's get the tube and just see if it turns on and what happens. Alright, so I got this hooked up here on a K7000 tube. The Neotec 2515C is fully compatible with K7000, K7400, U2000, Hanorex Polo, and even the U5000, because the U5000 yoke will handle standard res. So you got 5 different options to choose from, including the original 2515C monitor. So you have 6 different yokes and 6 different monitors you can use this with, and all those are all vice versa. So it's all of these chassis are a very uniform and interchangeable setup here. So we're all hooked up with anode neck yoke power ground video and remote. I forgot to mention the remote board inspection. All of the pots look good. So we're all hooked up, and for B plus here, you want to set it to 125 volts DC, 125, and you adjust it right there at where's it at? R112, I think it is. Yeah, R112, that pot right there. And you hook it up right here at that resistor right there. It's hard to see, but it says DC next to it, but that's where you want to hook up for your B plus reading on that resistor right there by that cap on that leg facing the inboard side of the chassis. That's where you hook it up for your B plus, and we're hoping to see somewhere around 125. If not, we will adjust it, but we're also hoping to see that it even turns on. So that being said, I have a video signal and a board hooked up, so let's go ahead and just count to 3 and see what happens here. 1, 2, 3. Oh, yeah, it's not even working. It tries to, it energizes and stops. Energizes and stops. I think we simply have bad caps or a bad flyback. Do I even get a reading on my B plus? Oh, 125.3 was perfect. So our B plus, when it does try and boot up, is perfect. That's a good sign. So it's still charged, though. It's not dissipating. So we're going to have to discharge our tube before we take this off of here. Because if this goes down to 0, like the 7000 or 7400 and the other series of Wells Gardner chassis, this will automatically discharge itself. Since it still has 42 stored volts, we're going to have to discharge the tube. And we can actually, you know what, we can do that by touching our alligator clip to ground. If I touch this to the frame, it should go to 0. Yep, there you go, 0. That discharged it, so we're good there. So you heard there, it tried to power up and then shut down. It tried to power up and shut down. We had 125.3 very momentarily. So I think what I'll do is I'll just do, we know that the switch mode power supply chip is not dead or bad, because it worked. It tried to work there for a moment. Like I say, if it's totally dead, doesn't do anything, that chip is bad. I've never seen it be bad in any other way other than just be totally dead. So I don't think it's actually bad. I don't think it reads the same. It's a different part number, so I don't think it's going to read the same as the one from the 7475 2000 5000. So that being said, let's go ahead and get this off of here, and I'll do a cleaning and a full cap kit and a reflow and a flyback and see if that makes a difference. Hopefully it does. I'm confident that it will. So I'll get all that work done. We'll come back and see what happens. Okay, boys and girls, gather around and let Uncle Mikey tell you a story here of hair pulling and gnashing of teeth and just general despair. So I've got this thing repaired to a point to where it's ready for testing and adjustment. But where I last left you, it's been 2 days now. Where I last left you, we had powered it up, and we saw it gave us an inkling of 125 volt on the B+, a quick flash of the correct voltage, and then it went into shutdown. And it was trying to power up and shutting down, trying to power up and shutting down. So I was able to successfully do an entire complete full cap kit, a full reflow, including remote board, all the neck work, full inspection, new flyback, and got everything cleaned using alcohol and a brush. So it's looking nice and minty fresh now. Including the bottom side, I was able to go through and do all the cleaning on it as well. It cleaned up very nice, all the pads, and I mean everything is factory fresh except for the rust and whatnot, but nice and minty fresh with no issues. So I recorded all of the attempts at that point to test it, and it didn't work out, and I must have probably tried to hook this up and run this thing about 10 different times, and every time it didn't work. It kept trying to fire up and shut down, fire up and shut down, fire up. So they go, you know, you could hear it make it. It wasn't going tick, 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 tick. That's an issue of a shorted HOT, but we tested the HOT and it was good. And it's still good. So it was not an HOT being shorted. When the HOT is bad, you'll hear it go tick, 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 tick like a 74, 75, 2000, 5000. So that wasn't the problem. The problem was it was going into shutdown. It would try and turn on and then immediately shut down. And I troubleshot this and troubleshot this and troubleshot this, and I just could not figure it out. Randy Fromm, the great Randy Fromm, has a flow chart for this, and I'll link it down below so you can check it out if you ever have to deal with this yourself. But it boils down to the horizontal output section is all of this area right here. You got the HOT and T401 and R424 and Q401. And what else is in here? You got the, I gotta change this back over to wide. There's 3 capacitors here. There's the width coil, and then IC401 is just, this is the exact same chip that's on the 74, 75, U2000, 5000. This chip right here is part of the power circuit. That chip here is the exact same chip that's on here. It is the LA 7851. It's the exact same chip on the Neotec 2515C as it is on these series of chassis here. So if we follow the flow chart, it says to check the HOT. That we know that was good. It still checked good. So then it says reflow all the pads for T401, which I did that. That wasn't the issue, so I went ahead and replaced it. Didn't fix anything. Still stuck in shutdown. It says to check Q401. I checked that. It checked good. I replaced it anyway. I have I ended up finding a donor chassis here with a missing neck board and a bunch of ripped off stuff. So all of these parts I robbed from this one. I went down in my stash and found this. I forgot that I had that, so that was fortunate. But I changed Q401 here per the trouble tree or the flow chart. Didn't fix anything. I changed, I'm sorry, Q401 was this guy. I changed Q401, no change, still shutting down. I changed the voltage regulator, which is over here on this side of the house, this guy over here. Changed it, no change, still shutting down. I removed that weird capacitor over here on the power side that was smashing down that resistor. I changed it out to the correct type that's supposed to be on there. Somebody put this in there, don't know why. It's not the right kind. Well, it's the right kind, but it's not the right footprint, and that's why I was smashing that resistor over. So I put the correct one in there, this orange film capacitor, so that's the correct one. That did nothing. So we changed out that cap, did nothing. We changed T401, did nothing. Voltage regulator did nothing. Q401 did nothing. R424 is this 3.3K resistor right here. The flow chart says to inspect that. It read fine. I changed it out anyway, just for good measure. It did nothing. It said finally, if all else fails, replace the U401 or IC401. The LA7851 chip. I have a little container here with like three or four of them in there from the 2005, 7500 series. And I replaced that with the known good one. This is a box full of known good parts. It did nothing. So here's all the old caps. So we're down to what I found. If I had hair left, it would all be pulled out by now. And 2 days I've been trying to struggle with this and thinking it might have been I changed the flyback twice, thinking it was a flyback problem. I re-inspected and checked every diode, every resistor, every transistor, the little NPN and PNP transistors on here. I checked every diode, resistor, transistor, capacitor. I even changed out the giant transformer here. I changed out the little built-in isolation transformer right there. I mean, I did everything you could humanly think of to try and get this to get out of shutdown, and it did nothing. I compared the shutdown pot reading to the reading. I have one of these in my multi-Mortal Kombat machine. I have a multi-Mortal Kombat machine with all 5 games in one cabinet, and it has one of these monitors in there. So I pulled this out of my MK cabinet and verified that the shutdown pot was reading the same as the one from my MK machine. That chassis was reading exactly the same, 3.1K. Okay, so the shutdown pot is set properly. So then I checked the B plus pot, and that's where I found the problem. The B plus pot is bad. And when I say bad, I mean really bad. It's supposed to be a 5K ohm pot. But let me show you what's going on here. It's very interesting. We'll go to ohms. Let's grab a couple of leads here. Clip on there. Clip on here. And if we go to the common, and we go to just one leg here, look at what we get. Open. Oh, sorry, you can't see it. Let's zoom in a bit. We have nothing. Now if I touch the other leg, I'm not even doing anything. I'm just holding it here, and look what it's doing. It's supposed to be 5K. It's bouncing around. It's probably not a good connection. If I just get a good connection here on the tip that was soldered in, it's still open. So we got oxidation on the legs, but if we just clip on the very end that was actually soldered into the chassis, and we touch the very tips that were soldered, open. We have an open or broken or bad. See, now it's in the mega ohm. Now it's way up in mega ohm, and then it just went away. We have a severely, severely bad B plus pot. So I had already pilfered this the B plus pot, which is R112. Right? I'd already pilfered it from this long ago, as well as the IC101. But I knew the IC101 was good because I had mentioned before that if this chip is bad, then the chassis is completely dead, but it wasn't. It was trying to power up and then shutting down. And so I knew that was okay. The reason it was doing that was because we had a bad B plus pot. Don't know how it happened, don't know what caused it, but I actually went, before I started making videos, I have a log of a whole bunch of folders of various, I don't know, 50 or so different repairs I had done in the past before I started making videos. And I went back and looked, and sure enough, I had a Neotec 2515C that had the same problem in the past. Now, for some reason, I had been doing this for so long that I forgot to go look and consult my previous repairs, and if I had done that, I probably would have found this 2 days ago. But it just goes to show you, live and learn. But the story doesn't end there. So I only have access, the only pots I have are 10K. I think the smallest I have is 2K, and then it goes up to 10K. I did not have a 5K ohm pot. So I put in a 10K ohm pot, which is this guy here. I put a 10K ohm pot in there, and I have it set to, I think, I have it set to the exact same reading as the Neotec that I mentioned before that I pulled from my multi-Mortal Kombat machine. I think it's 2.3K. Let's take a look here. I think it's 2.3. If we measure this to here, yeah, 2.3-ish, 2.25. Now that is exactly what it reads on my other one that's working out of the multi-Mortal Kombat. So we have a B+ pot set to what it should be to read 125, and I verified it's reading 124.8, give or take. So after replacing this pot, well, I take that back. Let me go back a few steps. I replaced the pot, set it correctly, so it has more range. So if you turn it up past 5K, you're going to take out the HOT. But in theory, you should never have to adjust it now, because this should last another 25 years after doing all this work to it. So this should never have to be adjusted again. But after replacing that, it was still in shutdown, and I just wanted to shake my fist at the sky and say, what the hell, give me a break just once. So after replacing that pot, I still had the shutdown. So I got on a whim, I decided to start tweaking the shutdown pot. And this one, they have it marked as X-ray. It's marked as X-ray, but this is the shutdown pot. So I mentioned before that I had this adjusted to 3.1K, which is exactly what it was adjusted to on the working Neotec out of my multi-Mortal Kombat. But it turns out that it didn't, 3.1 was incorrect. 3.1 is what it was set to from the factory, but after doing all this work to it and getting a different B+ pot in there, and how out of whack this got from having the bad B+ pot installed, I had to turn this to something different. I grabbed the screwdriver, and with this running, I showed you before, B+ is you hook up to this leg of this resistor, R117, and I was getting 170 volts. B+ was reading 170 volts, obviously way too high. It should be 125. So as I was adjusting this pot, I would turn it and shut the monitor down, turn it back on, and it would go into shutdown, 170 volts. Shut the monitor down, turn it a little bit more, turn it back on, and it would go to 170, shut down, turn the monitor off, turn it a little bit more. And when I turned it up, I turned it on for that third time, it came to life. I had raster, I had neck glow, I had 124.8 volts, good to go. So 2 days worth of troubleshooting and all this work and all this replacement and all this head scratching and banging and testing every resistor and every transistor and every diode and everything under the sun, replacing parts that I knew weren't the problem but did anyway just for good measure, replacing capacitors, everything you could think of. After all that work, it turned out to be simply a bad B+ pot and a shutdown pot that needed to be readjusted. So after all that, let's get it hooked back up, and you can see that it does indeed turn on. And then we can go ahead and make our adjustments and see if we can get a good looking image, because all I did was turn it on long enough to make sure I got good B+ and I got raster, and then I turned it back off and I turned the camera on. So it is not adjusted in any way, shape, or form, but I did make sure that it does have raster and everything. So you'll see. So let's get all this stuff out of the way. The only actual issue was the B+ pot and adjusting the shutdown pot. So all this stuff is actually good. So I'll hang on to all this, set it aside. So we have all the old caps and then the old flyback. So we'll set all this stuff aside. We'll save. Actually, you know what? I'm going to toss this B+ pot in here with all the bad caps. I like to send all this stuff back to the original owner here, so they have, besides the video, they have evidence that I actually did what I said I did. So that's in there. The rest of this stuff is all going to go in my little container of good parts. Okay, let's put some stuff away here. So, I like to do everything live on camera, but I was dealing with such a headache with this. It just got so frustrating that I just wanted to get it fixed and then talk about it after I found the fix. So I'm sorry if you were hoping to see a little bit more involvement with it, but I think I explained it fairly well. There's not much to the cap kit and flyback replacement, but We all know how to read a diode. We all know how to read a resistor. You want to read it out of circuit. If you go to read a resistor, it's supposed to be, let's say, like this is 3.3K, this big resistor here, R424. If it's supposed to be 3.3K is what's stamped on it, and you read it and it's like 35 ohms, obviously that's wrong. So you would take it out of circuit and test it and see if it reads 33K. You should test resistors out of circuit. But if it reads what it's supposed to in circuit, that's fine. If it doesn't read what it's supposed to in circuit, take it out and read it out of circuit. If it reads wrong out of circuit, then it's bad. If it reads correct in circuit, then that's fine. It doesn't need to be replaced. So it's kind of a mixed bag. It depends on how the circuit is operating. But anyway, so we're all cleaned and are all hooked up and ready for testing. I don't know why I said hooked up. I didn't mean to say hooked up. We're all cleaned and I'm just flustered with, scratching my head on this for 2 days. So let me get this on a tube. We'll turn it on. We'll measure our B+. We'll make sure it's all good. We'll get everything adjusted and we'll test it and we'll see how it turns out. Okay, we are hooked up and ready to go. We got anode, neck, yoke, ground, video, power, and remote board is here hooked up. Our B+ is sitting here idle at 1.662. That's still sitting there like that from the last time that I had powered it up before I turned the camera on to explain the problem. That's why it's not 0, but I just want to say I have not turned it on after hooking it up because I want to show you guys that it's actually functional before we do any testing and adjustments and stuff. So we are hooked up. It's over here, like I say. It hooks up to that point on that resistor right there. And see, anything else I want to mention? Before we turn this on, I don't think so. All of my color pots are centered still from the earlier, just a few moments ago for you, but 2 days for me. So yeah, I think we are ready to go. Video's hooked up. Alright, so let's turn it on. And hopefully we should see 125 volts or close to it. And if it's close enough, we'll call it okay. 1, 2, 3. Alright, 124.789. I will take that all day. And we got a sync issue here of some kind. H hold. I don't think my sync wire is hooked up properly. But we have an image. See that this stupid video connector on the Neotec is a 6-pin, and I've only got a 10-pin. You can see there that I've got to put that little jumper wire in there for the sync, and let's see if I can get that to... it's probably not connected here, so hang on a second. Focus, you stupid camera. There you go. Let's see if I can work some magic here. And alright, hang on. We know it's working. We know it's operating now. We know we have... Look at that, 125.3. Let me see if I can get this connection fixed here, and I'll come right back here. Hang on. Okay, so I got it all resolved. It ended up being, I had the jumper for the sync in the wrong pin. The Wells-Gardner connectors are, there's 10 pins there. There's red, green, blue, ground, and sync. And then all the way over there on pin 10 is the sync wire, the white wire. Well, I have my jumper on pin 10 there going over to pin 5. So red, green, blue, ground is 1, 2, 3, 4, and then pin 5 is empty, and pin 6 is supposed to be the sync on this 6-pin connector here. Well, I had it jumpering over from pin 10 to pin 5, so I actually had my sync in the wrong pin. So let's go ahead, and now that we have that corrected, it should work. So let's go ahead and turn it on, and please, oh please work, because if this doesn't work, I am going to just give up on everything. So here we go. 1, 2, 3. Yes, it comes on. Please, oh please, will you... Yes! Oh, I can't believe it. Oh man, the frustration that I went through on this. Now that it's working, it's just... I haven't had one that fought me this hard in a very long time. So, alright, look at that. Let's make sure we have, the colors are all wrong and we're way too wide. We're going to have to adjust our width coil, which is this guy here. See if we can turn it. Yep, other way. That's the limit that we get there, which is fine. We have a little bit of black on this side, so let's do H position right here. Yep, that works, and that's about equidistant. That looks pretty good. Vertical size. We have vertical size, so that's correct. There we go. Let's try brightness. Brightness needs to go down a bit. Contrast is all the way up. Yeah, we need to adjust our red, green, blue, but I'm not worried about that. We have, looks like we have vertical position works. Vertical position works. We've got vertical hold. Vertical hold works. We know we got pin cushion here. Pin cushion seems to work. Horizontal hold. Yep, that works. So all of our remote pots work. We know we are good for B plus at 125. And we have a good working monitor now. We still need, of course, to adjust our colors, but I'm not going to worry about that for now because it's not staying on this tube like I say every time. Oh, I'm telling you, man. Focus up, focus up. All right. Well, there you have it, ladies and germs, ladies and germs, as they say in show business or vaudeville. Man, this was a doozy. But you stick with it. Don't get too. That's already nice and focused too. Everything, isn't it? Yeah, not too bad. Not too bad. Colors are way off, but you know, every time I say I'm not going to worry about it, I always end up trying to adjust them here. Let's adjust our gains just to try and make it a bit better. Green. Let's turn blue down a bit. Turn red up slightly. And that's a little better. That's a little better already. Look at that. Outstanding. Nice job. Okay. Well, all right. It's about midnight, so I'm gonna have to let this do its 4-hour or so burn-in that I do. Like I say, if something's gonna go wrong, it's gonna go wrong in 4 hours. You know, you don't need to let these run for 8, 10, 12, 24 hours. There's no real reason to. If something's gonna burn up, it's gonna burn up in 4 hours, 3-4 hours. So that's just my philosophy. But it's working, and the whole time we had. Well, we might have had a bad flyback in caps, but I think our main problem was always this bad B plus pot that I tossed in here. So, well, lesson learned. So, hopefully you learned something on this one. I know I did. Thank you very much for watching. Stay tuned. Lots more content, and we'll see you on the next series of repairs.